Hey guys, today we are going to take a look at 10.5, which is called the general form of a conic. It's right there at the top. And what the idea is, we've already talked about the general form, but we talked about the general form of a circle while we were only talking about circles, and parabolas when we were only talking about parabolas. So today what's going to happen is you're going to be given an equation, and we need to identify what it is first, so that then we can rewrite it in standard form and, graph it. But you need to know, all the formulas look different from each other. So you need to know what shape you're dealing with before you start to put it in standard form. Okay? So this is general form right here. Okay? So you've got your x squared and your y squared together, your x and your y. This would be a constant. Okay? And all these capital letters are like the coefficients of the variables. Now you'll notice there's a b missing. It goes from a to c. In the book, they throw a bxy in there. Well, if you have an xy, it'll take like an ellipse and it'll turn it on its axis at an angle, and we are not going to worry about that. Okay? So they're going to all look like this. So we've got 4 different shapes. So here's what you're looking for. What you want to look at are these 2 things. That's it. You are looking for the x squared and the y squared term. That will tell you everything you need to know. If you have an x squared and a y, well, first off, you have an x squared and a y squared, okay, and the 2 coefficients are the same. So that's what this says. If a is equal to c, then you have a circle, okay? So those 2 numbers in front are the same. If those 2 numbers are different, so if a and c are different values, but they both have the same sign. So if that's a positive 2 and that's also a positive 2, then you're going to have an ellipse. If that's a negative 7 and then that's also a negative 7, you are going to have an ellipse. Okay, so they have the same sign, but they have to be different numbers. If they're the same number, then you're going to have a circle. Okay, so if that's a 2 and a 2, it's a circle. If it's a 2 and a 3, that's when you have an ellipse. A hyperbola, if you'll remember, the hyperbola has one of the squared terms is negative. Okay, so if these 2 have opposite signs, that's it. They could be the same value, like their absolute value could be the same. So this could be a 2 and this could be a negative 2. That's still a hyperbola. Okay, so 2 different signs, that is a hyperbola. Parabola only has 1 squared term. So when you're looking for both of the squared terms so that you can compare the numbers out front and you realize one of them's missing, that's how you know you have a parabola. Okay? So that's it. Those are the 4 rules. That's what we're looking for. Just remember, to be able to use these rules, you need to be in this general form, and then you can rewrite it in the standard form. Okay? So if you look at the examples down here, I want you to identify the conic. So first off, then once you know what it is, put it in standard form. Then we're going to sketch just a simple graph. Okay, so if it's a parabola, we're just going to draw the parabola. We're not going to worry about the directrix and writing down the focal point or anything. We're just going to graph it. Okay, so just quick little practice, making sure you know how to, a reminder of graphing. Okay, so the first example, I need to compare my squared terms. So I've got an x squared and I do not have a y squared. So right away, I know that this is a parabola. Okay? And now I can get this in standard form. So for a parabola, I want my x squared on one side and then I want everything else on the other side. Well, the x squared's already on the other side. There is no x connected to that x squared, which means there's nothing to complete the square with. This x squared is already good. That's already what I want on that side. So that means there's nothing to change on the left side. There's nothing to change on the right side. So this side is just going to stay put. I am going to factor out this 4, because we're always supposed to have a 4 out front. So y minus 1. And so that's the standard form of our parabola. It has a vertex at 0, 1. So 0, 1. This is a vertical parabola because of the x being squared. That's 4 times 1, so that would be our p-value. So I would go up 1, I go 1, 2, 1, 2. I go over 2, and that's my parabola, and that is all that I need from you today. Okay, just a quick little sketch. All right, look at example B. So, first off, don't get tricked. It's very easy to look at this and say, oh, I've got an x squared and a negative y squared, so that's a hyperbola. It's not. Notice that the negative y squared is on the wrong side. Okay, to be able to compare them, they need to be on the same side so we can tell what's positive and what's negative. So, if this was written as x squared plus y squared minus 6x, I'm also going to bring the 6y over, so minus 6y, that is now general form. And now that you've got the x squared and the y squared on the same side, you can see that that is clearly a circle. They both have a 1 in front of them. So now I know what I'm dealing with. X squared minus 6x, leave a blank. Y squared minus 6y, leave a blank. We're going to move the 18 over, a couple blanks. Switch colors here. So what's this? Plus 9, plus 9. All right, so we've got, what's that? X minus 3 squared, y minus 3 squared. 9 and 9 is 18, and 18 and 18 would be 36. Oh, well, that's nice. Okay, so that's our radius squared. I say that all surprisingly, like I didn't make up that number to make it work right. But anyway, oh, well, that's nice. Okay, so again, this is a circle. The center is at 3, 3. So 1, 2, 3, 1, 2, 3. So there's our center. And then we have a radius of 6. So let's see. I went up 3, so now I need to go 1, 2, 3, down. 1, 2, 3, 4, 5, 6. So we're going to say I'm going up 3. Now again, we're approximating here. Just do the best you can. I just want to make sure you're keeping in good practice with finding the radius and finding your center. But that's it. That's all I need from you today. Okay, just make a quick little sketch. C, what is that? What is C going to be? Okay, a positive 4, a negative y. That's a hyperbola. Oh, I didn't write. I said this was a circle. I didn't write it as a circle. Okay, this one's a hyperbola. Hyperbola. Okay, so now that we know what this is, I know it's technically not in general form. The 9 should be on the other side, but the 9 is actually where we want it to be. So as long as your x squared and y squared are on the same side, then you can compare them. Now, with a hyperbola, remember, we always put the positive one first. So we're not putting the x first because it's the x. It's because it's the positive. Not ready to complete the square. I need to get my squared terms by themselves. So this will be x squared minus 2x. We're going to factor out that negative. That's the hard part with hyperbolas. If there's not a number in front of the y squared, sometimes you forget that you're supposed to factor anything out. Okay? So, and also the plus 6 turned into a minus 6. Okay? All right. This is now a plus 1 and a plus 4. This is now a plus 9, but a minus 9. We are going to get rid of that little squared guy. He shouldn't be there. X minus 1 squared. Y minus 3 squared equals, the 9's cancel. And then when I divide, the 4 is going to cancel. So that's a 1. That'll be a 4. Alright, so this is a hyperbola. It's going to go in the x direction because it leads with the x. The center of this hyperbola is at 1, 3. So 1, 1, 2, 3. I am going to quickly like sketch that box. You do have to graph everything. I'm not going to ask you to write down the asymptotes and everything, but you do need to go over 1, up to, down to, make that box, make the asymptotes, and then I'm going to change colors. Since the x is first, it's going to go in the x direction side to side, and that is what I need from you today. Okay? All right, one more. Last one is an ellipse. Different numbers, but they're both positive, so that's going to be an ellipse. Okay, so what do we got here? 9x squared plus 18x, leave a blank, plus 5y squared. There is no y term. Okay, so if there's not a second term of the trinomial, we don't need a third term. We don't need to complete the square. This is good. We're all set. The only thing, so we're going to have one blank over here. So, oh, got to factor out my 9. I'm not ready. X squared plus 2x. All right, so what do we got? Half of that squared is 1. So that is a 9. 9 x plus 1 squared plus 5y squared equals, that's going to be 45, which is convenient because that's a 9 and that's a 5, and they're both going to cancel with the 45. Okay, so the 9 and the 45 will reduce when we divide everything by 45. So the 9 and the 45 will give you a 5. The 5 and the 45 will give you a 9. And that's a 1 over there. Okay, so quick little sketch. Center is at -1, 0. There's the center. I'm going to go in the x direction, whatever the heck the square root of 5 is. 2.2. Is that good? So 2, and then a smidge that way. 1, 2, and a smidge that way. We're going to go up and down. 1, 2, 3. 1, 2, 3. So these would be our major vertices, the up and down. It's going to look similar to a circle. It's not real stretched out, but that's it. Okay, so take a look at the worksheets. If you have any trouble, let me know. But I think you're going to be okay with this one. All right, thanks, guys.